Hey everyone, Mr. Fritz here. In this video, we are going to talk about solving basic trig equations with basic identities, or IDs. Let's jump right in and talk about simplifying trig expressions. So if I have 2 sine of theta plus 3 sine of theta, this really isn't all that complex. It's a lot like just adding and subtracting normal variables. This is the same thing as like saying I have 2x plus 3x. If we add 2x plus 3x, that's equal to 5x. If I have 2 of something and I add 3 of that same thing, I have a total of 5 of that same thing. So this is simply just going to be expressed as 5 times the sine of theta. So all those rules that you know in algebra about adding, subtracting, multiplying still applies to these trig functions, as long as you remember that this entire function is like its own entity. So I can't pull things out of it or stick things inside of it. Think of it, for lack of a better term, as like 2x or 2u or something like that. So now we've talked about that, we can talk about some basic identities. But what exactly is an identity? Well, we're not going to talk about identity like who I am as a person. I'm not defining what makes me me. An identity in math is a little bit different. So sorry, Derek Zoolander, we are not going to find out who you are through math. We're going to talk about identities in a mathematical manner. So like a classical definition is something like this. An inequality relation A equals B, such that A and B contain some variables, and A and B produce the same value as each other, regardless of what values, usually numbers, are substituted for the variables. In other words, A equals B is an identity if A and B define the same functions. So that's a whole lot of words. Let me explain a little bit about what that means or show you some examples. You've seen these examples before. These are identities. Here is an identity. This left-hand side is equal to this right-hand side. They are algebraically the same exact quantity. If I were to put in a value for A and put in a value for B on the left-hand side, it would equal the same thing if I did that on the right-hand side. And similarly, you have this exponent identity that you've seen before and used before. It is a true equation, or is a true equality. Both left and right sides equal each other. That's what a mathematical identity is. And there are trig identities. You know some of them already. So let's start off with some reciprocal identities. These are ones that you've seen before. Let's start off with the sine of x. So that is going to equal 1 over the cosecant of x. The cosine of x, that's equal to 1 over the secant of x. The tangent of x is equal to 1 over the cotangent of x. The cosecant is the reciprocal of sine, so it's going to look very similar. The cosecant of x is equal to 1 over the sine of x. And the secant of x is equal to 1 over the cosine of x. The cotangent of x is equal to 1 over the tangent of x. Now I should also add two other things. With our cotangent and tangent, we can also represent them using sines and cosines. So remember that the tangent of x is equal to the sine of x over the cosine of x. And the reciprocal of that for the cotangent would be cosine of x over the sine of x. All right, so those are our basic reciprocal identities, pretty straightforward. Pythagorean identities. This is going to be something kind of new. We call it Pythagorean because it's going to involve the Pythagorean theorem. And what I'd like you to do is I want you to actually pause the video, and I want you to graph all 3 of these equations. F of x equals sine squared of x, g of x equals cosine squared of x, and y equals f of x plus g of x. So you're actually going to be adding a third equation where you're adding those 2 previous ones together. So pause the video, do this on Desmos, and see what you can observe. All right, so here's my Desmos graph. I've got f of x equals sine squared of x, that's in blue. G of x equals cosine squared of x, that's in green. And when I add both of those functions together, I get this horizontal purple line, which happens to be the line y equals 1. So what do we gather from all that? That means that the following identity is true. This is Pythagorean identity number 1. Sine squared of x plus cosine squared of x equals 1. Now why is this called the Pythagorean identity? Well, let's think about the unit circle. So if I were to throw down a circle, and I were to think about the unit circle, then I can think about each of these coordinates, remember, is given by cosine of theta, comma, sine theta. So the x value is equal to cosine of theta. The y value is equal to sine of theta. And then the unit circle, remember the r, the radius or the hypotenuse, equals 1. So this is another way of saying a squared plus b squared equals c squared. Our Pythagorean theorem is true just the same for these trigonometric functions. So cosine squared of theta plus sine squared of theta equals 1. That's why it's a Pythagorean identity. It's based off the Pythagorean theorem and the unit circle. Now, keep in mind that if we know this identity, we can rearrange this any way we like it. But I could also make these other replacements. Sine squared of theta plus cosine squared of theta can be replaced by just the number 1. The number 1 could then be replaced by sine squared of theta plus cosine squared of theta. Sine squared of theta could be replaced by 1 minus cosine squared of theta. 1 minus cosine squared of theta could just be equal to sine squared of theta. Cosine squared of theta could also be replaced then by 1 minus sine squared of theta, and if I were to clean that up or finish this out, 1 minus sine squared of theta could equal cosine squared of theta. Now this isn't something you need to memorize. This is just something that hopefully you see is algebraically the same as this. If I were to subtract cosine squared of x from both sides, that's what this line is, right? So all I'm doing is I'm manipulating the Pythagorean identities. So that's Pythagorean identity number 1. Let's talk about Pythagorean identity number 2. And the way that we get these is we basically just do some sort of manipulation to this equation. And what I'm going to do is I'm going to divide everything by sine squared of x. That's a legal move, remember, because I can divide. If I divide everything by the same term, I'm keeping everything proportional. I have not changed the equality. I'm just making it look different. So let's now simplify what I've done here. Sine squared of x divided by sine squared of x, that's equal to 1, plus cosine squared of x divided by sine squared of x. This is where my reciprocal identities come in. And remember, the cosine over the sine is the cotangent. So this is going to equal cotangent squared of x. And 1 over the sine squared of x is equal to the cosecant squared of x. This right here is the second Pythagorean identity. We divide everything by sine, then we get this right here. All right, the third Pythagorean identity, if I divide it by sine, let's divide everything by cosine next. So I'll divide this by cosine squared of x, divide this by cosine squared of x, and divide this by cosine squared of x. So now, if I go through this and simplify, sine squared of x over cosine squared of x is equal to the tangent squared of x, plus cosine over cosine is just 1, equals 1 over the cosine, which is the secant squared of x. There's my Pythagorean identity number 3. Now, it seems like, great, I've got 3 more equations that I need to memorize. Well, really, you only need to memorize that first one, because as long as you can do some algebra, you can generate what the other 3 are, or the other 2 are, rather. And even that Pythagorean identity should make sense because it's based off of the unit circle, and it's based off of the Pythagorean theorem. So up next, we will talk about how to actually use these identities and do some simplifying of expressions.